Today we're going to go over making a program for a simplistic individual part using CAMWorks for our laser. So unlike last time where we actually used the nesting tool, all we need for programming in CAMWorks for a single part is just the CAMWorks add-in. As you can see, we have a part here with a bunch of internal profiles, external profile. So we'll just do similar to what we did in nesting. We'll go to our CW tab, and this time instead of having the actual material size automatically set, we'll actually go ahead and define it here. So we'll just double click on the stock, and as you can see from here, if I rotate this, CAMWorks automatically makes it the thickness of the material that I have and then makes the bounding box exactly the same. Generally what I do when I program here, if I'm going to place this on a piece of scrap, I will select the X and the Y, as you can see here in the lower left hand corner, and I'll add a 1/2 inch to them. So just go to 0.5 and 0.5, and I do that just so I have a little bit of buffer when I measure to place it on a piece of scrap. If you want it at the exact size, you can change these numbers. For thickness, I always just leave it the thickness of the part. So we'll just hit OK. Then we'll go ahead and we'll define our information in the machine. So we'll go ahead and edit definition. Again, you can right click or double click to open that box. Now if we look at our part, it looks like it's actually 3/16 of an inch thick. So we'll go ahead in our posting and we'll make that 11870. That brings up the tech table that we use for 3/16. So we'll put a name in our post processor. We'll pick oxygen because we're going to cut out of steel, and then put in our thickness. Once we have that laid out, the next thing we need to do is we actually need to define our Z direction, which way the machine is actually looking at this. So to do that, we'll just right click on the stock manager and we'll do a new mill part setup. And then you can see the arrow right here. Right now it would be trying to cut from the back side. This is the direction that the head on the laser is going to be. So we'll go ahead and click this face because we want it to cut right side up, and you'll see that the arrow changes direction. So we'll hit OK, and we now have a setup that's facing the right way for our part. Now from here there's lots of different options. We can go to CAMWorks and do extract machinable features. You can right click on the mill part setup and you can do recognize features, which will go find everything in that Z. Sometimes what I'll do when I have parts like this is I'll actually use interactive method. So what I'll do is I'll go and insert new 2.5 axis feature, and again to get to that I just right click on the mill part setup and then do new 2.5 axis feature. So I want to use a pocket, and then I want to grab everything that's internal to this part. So I'll hit inner loop, and when I click this face, what it's going to do is it's going to go find all of the inside pockets on that face. Makes it really easy. One click, we find everything. Then we'll click end condition, and then this will bring up the style. Now due to our tech database, we just leave everything the same here. The only thing that will change is we'll make this the thickness of our part, and we do that because then the Z depths will all be the same, so it makes it easy to change later. We'll hit OK. And it'll take just a little bit as it goes through and finds all these pockets. And then the last thing we have to add is we'll just add the outside perimeter of the part. For here, if it asks if you want to add a configuration, we'll just do copy and show copy for this example. We'll hit cancel. And now we have all of our individual pockets for our part. So the next step we have to do is we have to add a perimeter to cut the outside. So we'll go ahead and insert 2.5 axis feature, and we'll just pick a boss. Just grab one edge, it goes and finds everything on the outside. We'll go to our end condition, make this the material thickness again, and then hit OK. And from here we have all of our features for our part. So all we have to do is either click generate operation plan from the menu, or you can right click, select generate operation plan. It'll go find all of the pieces of geometry. You can see again with our tech database setup, it went and found all of the correct tools. So we can right click and say generate toolpath, or you can click the generate toolpath button from up here. And we now have all of our lead in and lead out set. Now generally what I like to do is for a part like this where it's a little more artistic and I want the lead in and lead outs to be similar in size, what I'll do is I'll pick the first one, hold down my shift key on the keyboard, click the last one, which will be all my internal profiles, and then I'll do a combine. And in your combine menu, it'll bring up a menu like this. I hit OK. And now if I make one change to a lead in or lead out, I can change them all at once. So for example, if I edit the definition of this and I go to my lead in, I can now change all of the information I want, hit apply lead in, lead out to all, and it will update all of the tool paths to be the same. Makes it easy to keep track of, and generally I like to do everything on the internal first, put them all together, and then I do everything on the external. And then so here's your external. If you wanted to change the location of that lead in or lead out, when you bring up this menu here, I can come over here and I can say, well, I want it to lead in and lead out here. So I just click on that line, hit apply lead in, lead out to all, and now my lead in's down here to where I won't see that bump when I go to make it. Now one thing you'll notice is my XY right now is set to this random spot on my part, where when we did nesting it always went down here to lower left hand corner of the sheet. One thing that's unique about doing individual part programming is I actually need to change where 0 is at. So to do that, you just go in your operations tab right here, you go to your mill part setup 1, you can right click and hit edit definition, and then this will bring up where 0 is going to be. Generally I use stock vertex, so I hit that bullet there, and then as I change it, you'll see now, if I look at this, I'm now in that lower left hand corner, which sets me a ½ inch in. So we'll hit OK. Yes, we'll regenerate all the tool paths, so now all the tool code is going to come from this corner, and it'll take just a little bit here. And then once we have that done, we're ready to do the post just like we normally do. So we just right click, post process, or you can click it up here. It'll ask where you want to save it. So we'll just go in our vault here. We'll go to training, single part, and then we'll just save it as whatever the serial number is for this file. And again, just like before, you can step through it, hit play to the end, or just hit fast, hit OK. And then our tool path shows up, so we'll do just like we did before. We'll change that to 800 for example, and then we'll just replace some of the information that we want to get rid of. Like we want to get rid of all the rest of the 1200s, we want to get rid of any 90s, just because we want to control it from the TechDB right here. And then we'll go ahead, we'll just paste that. And there's no more Z's because we actually set our material thickness down and everything else is set the same. And then the last thing we'll do is we'll go to a Q27, G71, which will actually bring the head up to full height, and it will actually move it to the center of the table. And then if you need to move this around the sheet on your scrap part, you can actually go ahead and just change your X and Y here to the correct location you want it to cut, and it will go ahead and move to that location.